Welcome everyone. In this video, we will be discussing about uniform plane wave and also finding the wave parameter from expression of plane wave. So now we'll discuss about uniform plane wave. A homogeneous and harmonic plane wave is a constant frequency wave whose wavefronts meaning the surface of constant phase, are infinite parallel planes of constant peak-to-peak amplitude normal to the phase velocity vector. So look here, I draw the wave, and if you say the maximum and minimum point, you might assume the wave has a number of parallel planes with constant magnitude. So if you replace your wave with this analogy, this type of wave can be written as uniform plane wave. So basically, uniform plane wave has a constant magnitude, amplitude. If the wave, while the wave is propagating and the magnitude is not changed while it is propagating, that is called uniform plane wave. So if the magnitude of the wave doesn't change with the propagation distance while it is propagating, that is called uniform plane wave. As we have derived the wave in free space or perfect dialectic, that means it is lossless. So it is obvious that the magnitude will remain constant. But it is only assumption, just theoretical case. In practical case, wave will be attenuated while it is transmitting in a lossy medium. So there is no lossless medium in real life. But however, we are assuming our wave is uniform plane wave. So the amplitude is constant everywhere, and the planes that we have used to represent the wave phase or wave fronts, that is in perpendicular with the direction of propagation. So here we draw the sketch the electromagnetic wave or sine wave or cosine wave. So you see the amplitude, and there's the highest of this amplitude is called the crest and lowest amplitude is the throw, and this wave is traveling with respect to time. So we can find the wavelength of the wave from this sketch. The distance between two successive minimums or maximums is the wavelength, and also we can find the oscillation period or frequency. So the time it requires to oscillate the signals or repeat the signals is called the time period or the frequency, and how many oscillation we can find in per second time called the frequency. So we can find the time period from this wave from the diagram that shown here. The time period is t equal to 2 pi over omega, that is 1 over f. So you can find the time period and frequency from the graph, and also you can find the wavelength. Wavelength is the distance between two successive points of same phase, and wavelength also can be obtained by this formula 2 pi over beta. So and beta equal to omega times square root of mu epsilon, and omega equal to 2 pi f. So if you cancel them, you can write it like u over f. So u is the propagation, that is 1 over epsilon, square root of mu epsilon, and f is the frequency, that is equal to 2 pi f. So you can write u over f. And the speed of propagation, that is the phase velocity, you can derive the expression for speed of propagation. So as you know, the phase will be constant. Omega t minus beta z has a constant phase. So we can take the derivative with respect to time. You will get omega equal to b dz over dt, and dz over dt is the speed, distance over time, that is equal to omega over beta. And also you can find, so you got u equal to omega over beta, and beta equal to omega over omega square root of mu epsilon e. So 1 over mu epsilon e is equal to the propagation direction. So if for free space, you will get u equal to 1 over mu naught epsilon naught, that is equal to c, light velocity, velocity of light. So now from the wave equation, this is electric field equation is known. If the electric field equation is known, we can find magnetic field by using Maxwell's equation. The Maxwell's equation says curl of Es is equal to j omega bs Hs.
j omega mu Hs. So we can find Hs equal to 1 over j omega mu curl of Es, and curl of Es I replace with the Cartesian system. So here we have Ax, Ay, Az, and partial over partial x, partial over partial y are 0 because there is no x and y in the E field equation. So it is not varies in terms of x and y, but this is varies with respect to z. So you have dz partial or partial z, and there is no y and z component. So you put y and z component 0, only the x component there, and then you expand this and solve this expression. So once you solve it, you will get H is equal to j b j omega mu e x naught e to the power j beta z a y. Cancel j from both sides, so you will get b over omega mu e x naught e to the power b z a y. So here e to the power b z, sorry, I remove I missed a j sign, j on the final answer. So if you say the phase angle is beta z and b omega mu E x naught is the amplitude of the magnetic field, so we can write it the amplitude y0. So hy0 is beta omega mu E x naught. So hy0 is the amplitude of magnetic field. From the previous case, if you divide h y0 over E x0, or in general you can divide the magnitude of h sy and exs, you will get omega mu over beta, and replace beta with omega mu over epsilon, you will get epsilon naught mu over epsilon, that is equal to the impedance, that is called intrinsic impedance or wave impedance. This intrinsic impedance is the medium impedance. As you know, that is contribute to the magnetic field and electric field, or you could say voltage or current, right, in large scale form or in circuit point of view. So that's the impedance, wave impedance. So wave impedance can be defined as the magnitude of frequency domain magnetic field over the magnitude of frequency domain electric field. So impedance is the ratio to the magnitude of frequency domain magnetic field to and the magnitude of frequency domain electric field. In free space, the wave impedance will be eta naught equal to mu naught over epsilon naught, and that is equal to 120 pi. So for free space, don't forget to write the suffix naught, 0, suffix 0. So beta should be beta 0, eta should be eta 0, like this. TEM wave. TEM wave is called the transverse electric and magnetic wave. So if you see the expressions that we have obtained before, the electric field and magnetic field, they are perpendicular to each other and also perpendicular to the direction of propagation. So this type of wave is called transverse electromagnetic wave. So both electric and magnetic wave are perpendicular to the propagation direction, and also they are perpendicular to each other. So now we can find the direction of propagation by taking the direction of E field with cross product of direction of H field. For example, the direction of propagation AP is equal to the direction of electric field cross the direction of magnetic field. So now for TEM wave, we can concise the magnetic field or find the magnetic field from electric field by using this formula. SS is equal to AP cross ES over eta, and ES is equal to eta times SS cross AP. We also can find some few more wave parameters, that is phase constant, phase velocity, wave impedance in terms of free space. So you see the phase constant is this, and the phase velocity, the velocity is u over 1 over epsilon mu, and the wave impedance eta equal to mu naught over epsilon, and Hs can be obtained by using this formula for TEM, like SS equal to AP cross ES over eta, and ES is eta times SS cross AP. So here is an example to solve. So you have a you see the question says starting with general point of form of Maxwell's equation frequency domain, drive and solve one-dimensional wave equation in terms of H field for linear isotropic homogeneous perfect dielectric in the field of propagation if the field is propagating in the positive x direction and varying in y direction. I recommend you practice this question, and this is very important question for the midterm test. And here is another question, numeric question. So a plane wave propagating in non-magnetic dielectric has E equal to 50 sin this. You have to find the direction of propagation, phase constant, frequency, wavelength, relative permittivity, wave impedance, time domain, magnetic field, and frequency domain magnetic field. Here you see the solution for this. The direction of propagation is along AZ, negative AZ direction. So the wave is propagating in negative Z axis, and beta is equal to 2 radians per meter, lambda equal to 2 pi over beta equal to pi, omega equal to the power 8 radians per second. Frequency is 15 for 2 pi over omega over 2 pi. Beta equal to omega mu over epsilon. That is, we know that, and from this we can find epsilon r equal to 36. Impedance, wave impedance is 20 ohms, so we use this formula. And ES, the electric field expression, so we got this, and the magnetic field expression is here.